They are going to be talking about tooling for roguelikes and Procgen. They're a senior game design engineer at Monomi Park and a roguelike tinker and enthusiast. They've spoken here a number of times in the past on various things, including very memorably a ritual system set, which was pretty fantastic. But this time they're talking about tooling and how we can make specialized tools for Procgen and roguelike development. So without further ado, take it away.
Awesome. So thank you very much. And thank you all for coming to listen to me talk about tooling. My name is Spencer, and as Kawa said, I am a game engineer at Monami Park. I'm working on Slime Rancher 2, which is not a roguelike, but some of the same stuff that I'm going to talk about actually still applies. And in my free time, I'm a dabbler in Procgen and roguelikes, which means that I have a lot of projects that I've started and never finished or released in any form. So when I signed up to do a lightning talk, but I live in California, so I don't really know what lightning is. So instead, I'm going to talk about tools. And the big idea that I'd like you all to be able to take away from this presentation is that you can build and use tools for your roguelike, for Procgen, for your team, for yourself, for non-engineers or people who aren't involved in coding. And you can build, like, tooling is, such a broad topic. So I'm definitely not going to cover literally everything because that would be, years of a talk, and I'm here for, 10 minutes. But we can do lots of interesting things with tools in roguelikes and in procedural generation. So what do I mean by tools? What I'm going to be talking about specifically is content creation tools as they relate to procedural generation. And so I mean software that helps to create content for the game by creating the procedures in the procedural generation. These provide kind of a non-code interface around the game data. And I have a little asterisk next to non-code because I am using that term here, but I think it is sometimes kind of a misleading term because things like visual scripting or domain-specific languages are tools that help to create these kinds of things, but they are also, in a way, code or equivalent to code. So saying that like a visual thing is not code is not entirely accurate in my opinion, but I'm using the shorthand here because I mean not literally writing code like in an IDE and an editor like that. So to demonstrate this, I'm going to quickly step through a case study in dungeon generation because that's something that I think a lot of folks here are familiar with. And the dungeon that I'm showing here is what I'm going to be building a tool to generate. And it is one of the most basic dungeons that I think I could think to make. The steps for it are you start with an empty area. You use binary space partitioning, which, if you're not familiar, is a way of just taking a space and splitting it in half repeatedly until you get a bunch of little areas, usually rectangles. In this case, they're rectangles because we're starting with a rectangular area. We're going to fill each of those regions with a prefab room. You can actually see in the example here, I only have two shapes of prefab room, these kind of Space Invader-y looking ones and these sideways Tetris T blocks over here. And after we have all of those rooms, we want to wire them all up with some hallways. Here I'm using an A-star pathfinding algorithm. The exact algorithm isn't really relevant, but I like to use A-star so that I can have hallways like skirt around the edges of other rooms and stuff. You can do it much more easily than that. Anyways, so that process looks like this, where we start and we divide up the area, we place some rooms, we connect them all. And we can look at each of those steps individually. And that's actually what I'm going to be doing for creating the tool to build dungeons like this. So the 4 steps that I have shown here are the empty level, the binary space partitioning, the prefab room placement, and then the hallway connection. And we can build a tool to do this. And in fact, I did. And this is what this looks like. So this is a tool that I built in Unity using a framework called Xnode, which is an open source library for Unity that allows you to create these kind of visual node graph interfaces very easily. The actual setup time to get the UI parts of this where I can drag and drop nodes around was, on the order of a couple hours maybe. So super powerful tool if you're working in Unity. I highly recommend checking it out. And I'll have a shout out for that at the end of the presentation. But this is the process that I described earlier, represented as a node graph. And so you can see going from left to right, we start with a blank level. We do a binary space partitioning. So all of these colorful rectangles are the areas that we've divided that big area into. We're placing some prefabricated rooms in here, and then we're connecting them up with A star to make hallways. The second to last node there, I have actually placing the player spawn. So, non level geometry things can also be part of this process. I can incorporate, any part of the overall process can be part of a tool that you're building for it. It doesn't have to just be limited to the geometry. And we can actually look at a slightly more complex example that basically handles the case where our binary space partitioning has divided out some areas that are too small to fit any of our prefabricated rooms into. And we're going to branch. So I have a node up here at the top called region has room that just takes the regions that come in. And if they have a room, it pipes them out through one output node. And if they don't have any rooms in them, it pipes them out through the other one. And that allows us to branch in a kind of if then else manner. And if there's no prefab room placed in there, then all I'm doing is filling out some square rooms, which are just, carving out the rectangle that fits inside of the area with some padding on the sides for walls, and then piping all of those back into the A-star hallway carver. This is a super simple example. Obviously there's a lot more that goes into dungeon generation or any procedural generated content of any complexity. It'll probably be more than 5 or 6 steps, and there will probably be more branching and logic. But I hope that by showing you this, you can kind of get the idea and maybe think about how you could apply this to, not just dungeons, but any kind of problem where you can identify all of the component steps and break them down into things. So in this case, I've broken them down into nodes, but it could also be, layers in a list or any other kind of representation that is useful for you to work with. And as I said, it doesn't have to be just one thing in here with the geometry. I could also be placing enemy encounters in here. I could be using this tool to place loot. I could be using it to generate loot. So if I had nodes that were like, item base, item curse, and, piping through those different nodes, generating an item along the way, I could be doing that in exactly the same way that we're doing a dungeon here. So to kind of summarize the general approach that I go with when I'm doing any kind of tooling like this, as I've said, the first thing is to kind of break it down into modular self-contained steps. And these kind of become like Lego pieces. And so the more reusable and interconnectable your Lego pieces are, the more expressive power you're going to eventually have with that tool. And you'll want to expose parameters on these. So if I actually go back to the previous thing on the binary space partitioning node, the second one in the list there, I actually have a number of parameters like the max and minimum size that it'll divide things up into. So exposing those parameters, provides more power to each step in the process as well. The secretly hard part of all of this is making it friendly to work with. So, finding frameworks that make the user interface part easier is always a boon, because then you don't have to worry so much about that when you're um, trying to build the hard procedural generation part. So real quickly, I just want to shout out some existing tools that do this. Actually, a few people have shown off their cool tools in talks today, so I was really excited to see that. And I'm sure, a lot of people have their own little tools that they've built for things, or not so little tools even. So this is a thing called Dungeon Architect. It's available for Unity and Unreal, and it creates dungeons based off cyclic generation. So if you've heard the really great talk by the Unexplored developers about how they do cyclic dungeon generation, this tool is built off of that. It's super impressive. It's way beyond the little demo thing I put together. Super neat. This is Xnode, which I mentioned having used. It's available on GitHub. It's a framework for building these kind of node charts in Unity. And this is Celix or Skelix procedural engine, also for Unity, and it uses a similar approach, but they have different examples, like doing trees and buildings and such. So that is my talk. Thank you very much. You can find me on Twitter at Spencer Egart, or on itch.io at zeno.itch.io. Thank you.
Hi, I'm back. I exist. So that was extremely cool. That was super fun. It was great. We have time for maybe one question before our next speaker is on, and then at the top of the hour, if you're available, we've assigned the Rogue breakout room to you. And the question that I had, honestly, was how do you balance time building a tool versus time implementing stuff in a game? It feels like it'd be very easy to just get constantly stuck in building and refining tools and tool UI and then never actually make a project happen.
Yeah, that's actually a really great question, and a very so funny story. The demo thing I was showing off, the dungeon generator that I had created, it is very hilariously in a project titled 7DRL 2021, which I did not ship a game for 7DRL.
And for the audience that might not be familiar, 7DRL, if you want to explain.
Yeah. So it's a 7-day roguelike development game jam. So on the in the interest of time versus tooling, that is not usually a situation in which you would want to invest a lot of time building tools, because you are on such a tight timeline. I think it really does come down to you can make a very kind of mathematical judgment of time saved versus time invested, if you want. And that is something that, in kind of professionally, when I'm looking at building tools on Slime Rancher, that's one of the big considerations is this going to save everybody a lot of time while taking me a little bit of time to create? Or, am I going to invest a ton of time and people are not going to really gain anything out of it? So that's really the kind of mental calculus that goes into it a lot of the time. Sometimes you're building tools for the broader range of expression that they give you, and then it's harder to kind of put that into a strict value, like time value equation. So then it kind of becomes more of a judgment call. But usually you don't want to do it probably in a game jam scenario if you don't have the time to do that. Don't do what I did.
do as they say, not as they do. Excellent.